Today we continue to work on our Tower Blocks 3D game using Raylib. And first of all, I would like to show you and remind you how the end result would look like. So we have this kind of a game where we have these blocks, which you need to either click the mouse or press the spacebar, and you try to stack the blocks perfectly, and whatever part is not stacked on top of the previous block, it gets cut off, and you try to survive as long as possible. You can see the score on top. You try to beat your high score. The speed increases with every single block, and in the end it's just game over and you restart. A few like fancy animations here and there. That is pretty much everything we're trying to achieve. Last time we managed to set up our 3D scene. We have this initial block. We added some interaction where we, based on our input, we add more blocks on top. Our camera doesn't have any smooth movement yet, right? It's always looking at the top block here. And today we are gonna try and work on the moving parts. So the top block is moving forward and back, either like on x-axis or z-axis, while the y-axis is actually like this one, looking to the top. So let's jump straight into it, and let's try to see where we can start. All right, so first of all, we have this block definition, which has, so each block has its position, its size, and color. We init our game by having an empty array of place blocks. Then we push the default block on top of it so that we show it. And our update GameState has this temporary button pressing functionality, the handler, that simply adds a block on top. So we will probably just drop that eventually. So right now what we are trying to do is we're trying to make a block move. So let's add another property called movement, and let's try to define it. When we're talking about blocks movement, what we are interested in is its speed. So the speed of the block is increased with each block spawned, right? So the more blocks you have managed to pile on top of each other, the faster the blocks move. That's why we need to keep speed for each block. Then we would need some sort of direction, whether it's forward or backward. As you saw in the gameplay, it's moving forwards, backwards. Let's define a simple enum saying that, hey, we can have a forward direction and backward direction. And finally, we would also like to keep track of an axis where this movement happens. So in 3D, we are pretty much working with either x-axis or z-axis. Oh, too many typos here. Because y-axis is actually looking on top, and that's where our blocks are being piled. So we're gonna move our blocks either on x or on z. Okay, so we now have a new property which we need to default, saying that default movement is actually no movement at all, meaning the speed is 0, direction can be forward, doesn't really matter, and axis can be x-axis, something like this. So we need to take a look at our game. Currently we have initially like empty array of place blocks, and we put a default block as the first one, which is not moving. So the default movement is actually like speed has speed 0, so it will always stay in place at origin, which is 0, 0, 0. This is exactly what we want. And now we want to spawn a block that is moving, and we want to keep it separately from placed blocks because it hasn't actually been placed. So we will say something like current block is also going to be default, and it won't be like a pointer, it will be the full structure current block. We can also add something like a previous block, right, to keep track the top block of this placed blocks. So for example, here we can say that previous block is actually game placed blocks at 0, because we know there's only one element inside placed blocks array, and we're referencing that or keeping a pointer to it. Now, in our main, we are now interested in drawing current block, right? Given a game, probably reference. Let's also update this function to use game, so that we keep everything consistent throughout this series placed blocks. Right, so we are drawing current block. Let's see what we can do there. Draw current block, given game, probably even const, so we won't be changing, although that might not be needed right now. So pretty much we are interested in drawing current block only when the gameplay is active. As you saw in the beginning of this video, when I showcased the full gameplay, first we are in a sort of ready to play, awaiting user input, and there is no current block shown yet. And when the game is actually finished, when it's game over, there is also no current block, because, well, we failed the game and no current block is spawned. So we need to kind of check whether the game state is not, let's say, like playing state, then we can return. So we kind of need to introduce the state for the game as well. So it will be something like GameState state, and we can introduce enum GameState, pretty much as discussed before, something like ready state, playing state, and probably like game over state. When we initialize our game, we can say that state is ready, and here in our update game state, we are going to drop this temporary input processing and add a switch based on game state. We can populate the switch quickly with no ops for now, something like this. And then we can say that if I'm in ready state and input is pressed, so either the mouse has been clicked or the spacebar has been pressed, we can now say that, hey, game state is playing state, and game current block is something like CreateMovingBlock given our game. So let's see what this CreateMovingBlock does. Right, so pretty much we're interested in creating a new block which has the same size as the block on top of like placed blocks piles. So we already know that target is like the block below us, and we have it right here, previous block. right? This is the target. We can say that let's return a new block. Let's grab all these properties that we need to supply and see what we can do. So let's say same as target, same as target size, color same as target color, everything is the same for now, and target movement. And if we run it, this is our ready state. We don't draw anything, and if I press spacebar, nothing really happens. This is because our position is the same as target, so we are pretty much drawing on top of our placed blocks. But actually we aren't even like drawing anything here. We actually need to say draw block, which we need to pass game current block. Right, so in case we're in playing state, we are drawing that, and in CreateMovingBlock we need to somehow do some adjustments. So first of all, let's adjust the position. If we take our target's position and then we need to move our block up a bit so it's on top of our previous block, it means we can say that let's grab its height and simply apply it to our position Y. This way we can probably see the block. So we are again in ready state. Now I'm pressing spacebar and the block appears. But if I press spacebar one more time, or many times, click, nothing happens. Let's see. Like, one thing I don't like is that we're currently relying on GameState knowing that it is there. So let's quickly add things. Let's say let's draw game start overlay, draw game overlay, probably something like draw game score. Let's pass game to every single one of them. Let's also draw FPS so we can see how good we perform, and add these couple of methods here, which will simply draw some text so that we understand in which game state we're currently in. Let's see how we can do that. So let's say draw game start. What we want to do is we simply want to say, okay, let's draw some text. Right, so it will have some title, add some position. Let's say position Y, doesn't really matter for now. Font size and something like dark gray. Title here is let's start game, something like this. Font size, let's say something like 60, and now position, this is like X position, so we can say that this is something like screen width minus text size divided by 2. Come on, divided by 2. So what is screen width? This is our like game field screen width, and text size, we need to measure it. We need to measure this title, and we divide it by 2 so that we are drawing the text in the middle of our screen. And this can be achieved by using measure text, where we use our title and our font size. Why did I pass game here? Pretty much we only need to draw this overlay in case our game state is ready, right? So if it's not ready state, we can return and not draw anything. Now we can simply, for now, copy these things. We are drawing the score only when we are playing. For now, it will be like, let's say, 100. This is just a placeholder that will help us identify which game state we're currently in. We will rework this in a later episodes where we will add some animation, transitions, and so on. And game over is pretty much game over state. We can say game over, something like this. Let's see whether it works. So we are currently in ready state. It shows start game on top. I'm pressing spacebar and we are in our playing game state. We're showing the score, our current block, which we will make, which we will try to make and to move it so that it's constantly being animated. But for now, we cannot reach the game over state for now, but it should probably work the same way. We can see that our FPS is crazy right now. We don't need to burn that much CPU and GPU time. We can simply say set, what was it, frame set target FPS, right? Set target FPS, let's say 60. If we run it again, we are capped at 60. This is enough for us. All right, so now that we know which state we're in, we can get back to that CreateMovingBlock. So our position is currently on top of the previous block. We will use the same size as the block below us, which is fine for now. We will use the same color, fine for now. We will adjust it later. And what we would like to do is to adjust the movement property. So let's say speed is something like 12. I think that's our size is 10 by 10. Speed, we can actually adjust it later on. Our direction, let's say forward direction, and axis is x-axis. Right, so for now we just write something directly, but we will apply some randomization here. For now we would like to make this block, to make it move, to make it flow on our screen. I believe this is enough for now, and what we need to do next is actually start updating the block based on the time that has passed since last frame. So as usual, let's grab delta time and we can update current block. Not too many mistakes. Current block given game. Alright, so this is a method that is going to actually move our block, make it move. Again, first of all, we need to check if game state is not playing state, right? No need to do anything. We can return instantly. Otherwise, we need to understand which axis we're moving. So something like axis position. We can probably grab pointer to our game current block so that we don't need to type it out all the time, game current block. So if block movement axis is x-axis, then we need to grab block position x. Otherwise, we need to grab the z position. And then we need to say that, hey, axis position plus equals something like direction of the block times block movement speed times delta time. Now the thing is that axis position is a local variable, and we can then of course use it to set the correct position, but we can also simply have it a pointer, take a reference to either x or z values, and then make the change directly to the axis position so that the block value is updated in place. dt, yeah, we forgot that we need to pass the delta time here. So delta time is here, and now direction. What is direction? Pretty much if our direction is forward, right, we would like to add this kind of value to the position so that the whether it's x or z position, it increases, and in case the direction is backward direction, right, we would like to subtract. So let's see, direction is something like, we can say if block movement direction is forward direction, right, then it's 1, otherwise it's -1. Let's see what it does. We're starting the game and the block is moving, which is great, but it simply runs out of the screen, and that's it. So really we would like to limit the amount of movement that it does based on the axis. So let's introduce some constant saying let's say, I don't know, like movement threshold or something. Let's say again like 12, and we can check here that if axis position is greater than our movement threshold, maybe even like equal, and because we're moving in negative and positive direction, this can be either negative or positive, we need to take an absolute value, which is from math. And once we detect that we have actually moved the amount that we're interested in, we can now reverse the direction, which means that we need to tell that movement direction is what? If our current direction is forward, then we will make it backward, otherwise make it forward. And one thing that we also need to do is probably clamp this value to this threshold. We can do it by running max and then minimum. So first of all, minimum between movement threshold and axis position. So if axis position is greater than movement threshold, this minimum or fmin will clamp it to movement threshold. And the next is maximum, which says that if we are in negative values and we are smaller than minus movement threshold, then we clamp it to minus movement threshold. Let's run it and see what it does. And the block is moving forward and backward, which is nice. Let's adjust our CreateMovingBlock. Let's work on this direction and axis. We would like them to, probably we can alternate the axis. So if previous block was x-axis, current is z, next x, next z, and so on and so on. Alright, how can we do that? We can say that axis is what? If target movement axis is x, then ours is going to be z, otherwise x. And the direction can probably be random. Right. So we can say that direction is some get random value 0, 1. If it's 0, then it's forward direction, otherwise it's backward direction. If we run it, we can see that it shows, I think it's z-axis, right? If we run it again, it will always choose z-axis because our initial PlaceBlock is actually set with x-axis. Now, yeah, so sometimes it starts moving this way, sometimes it starts moving backwards. So it's forward or backward. I'm trying to see whether we can, yeah, so the randomization works. All right, so this is nice. And what we now would like to do is to actually interact with the game. So when I press spacebar, I need to figure out how much I have overlaid the underlying block. Based on that, make some calculations, produce a block on top of our PlaceBlocks pile, and create another moving block on top of that. So let's do just that. Where are we going to do that? Probably in our update GameState. So if we are playing, our current block is moving, and if we pressed either spacebar or clicked our mouse, we can say, hey, please place the block and spawn new one. Right, so let's say PlaceBlock. What can we do here? All right, let's first just see how it works and do it like this. So game PlaceBlocks, game current block. So we're pretty much saying that grab the current block and put it on top of PlaceBlocks. There is no like overlap, overlay, collision detection whatsoever. So wherever the current block is, we simply put it on top of block and then create another moving block on top of that. So this will look like this. All right, so it is creating the block, but it stays at the same position. So here we can make a quick fix saying that previous block is something. So first we need to grab the length of our placed blocks and then say that, hey, give me the last one, references previous block. And this way, when we start pressing space, right, it's actually taking into account the last placed block, and all the movement is based on the underlying block. That is why we can build this weird structure, which is not really what we want, but it's a good start. So we need to do some calculations here. Let's start with, first of all, grabbing some references. So game current block, and our target is game previous block. So these are two blocks that we are working with: current, which is moving, and target, which is right below it. Let's also grab some values like current position, bool is x-axis. We can check whether current movement axis is x. We can say that, oops, is, if it's x-axis, then we need current position x, otherwise current position z. Then target position, we grab target. What else do we need? Maybe we need current size, right? Based on the axis we're working with. Not entirely sure, but probably we'll need that at some point. So right now we have the position of our current block, position of our underlying block. We have the sizes of the block based on the axis that we're moving. If you understand the game and you saw how it's played out, you understand that initially it is a square, but as the game moves on, some parts of that square are being cut off and we are left with rectangle. That is why the size represents the current side of the rectangle, and it can be different whether it's X or Z. Alright, so knowing these values, what can we calculate? Probably we need to first understand that delta is my current position of my block minus target position. So these are positions of their centers, right? So when we are drawing this shape in Raylib, we are supplying its origin from which the cube, so to speak, with its sizes is being drawn, and we know the difference based on the axis we're working with. So if our current block is exactly on top of target block, then their positions are the same and delta is 0. But if current position has slided over or didn't fully cover it, this delta can either be positive if current position went over the target position, or it can be negative if it started to cover the target block but didn't fully cover it. And then we can probably say that overlay is like the amount that we have actually covered is what? It's like target size minus delta. So this is like the amount that is actually covering our top block, covering the underlying block. This is on this axis that we're working with, either X or Z. First thing that we probably need to check if our delta is less than 1%, pretty much 1%, because we start with X and Z being 10, right? And 0.1 is 1% of that 10. We're saying that if our delta is less than 0.1, we need to return. And we need to somehow tell our game that this is game over. But in case delta is bigger, it means, or is it not delta, is it overlay, right? Yeah, it's overlay, it's not delta. Because that small delta means that the block is actually covering really well the underlying block. So if our currently moving block only overlays the underlying block by 1%, this is game over. Yeah, like what else? Now we can actually say that, hey, if it's X and otherwise. So what can we say? We can say that our current block, its size on X is actually the overlay, right? So the amount we calculated. And then we can say that position X is what? It's actually target position plus delta divided by 2, right? Because we have delta represents the amount we have outside of our target, how much we're outside. It can be either positive or negative. And then we need to adjust our new center based on target position and the delta. And as we need to cut off, so to speak, the same sizes of delta from left and right, we divide it by 2. Same should be applied to Z. So if we're working with x-axis, we're applying the sizes to x. If we're working with z-axis, we're applying these changes to z. Let's see how that works. Alright, I think we will need that, so I will mark it as maybe unused. But other than that, let's check it out. Oh wow, it's growing. Very interesting. Alright, this is because, as I said, delta can either be positive or negative, and imagine that delta is negative. Minus delta is pretty much target plus some positive value, so we need to make sure that we grab the absolute value. All right, let's check it out again, and it seems to be working. All right, nice. So one thing I notice is that our speed doesn't change in the gameplay. If you're playing perfectly every single time, there is no problem for you. That is one issue. Second issue is that, maybe not an issue, that as you can see, the block is spawned at the same time or at the same place, like it starts from the middle, and we would like it to spawn at the edge. Right? Let me show you what I mean. When we create moving block, right, we grab the target position and simply adjust the Y. But what we would like to do, we can say that if axis is X, right, then we can say that our position X is what? If our direction is forward, then it's -1, otherwise it's 1 times movement threshold. And for Z, it's the same. So imagine this, we're spawning the moving block with direction, let's say forward direction, let's say at x-axis. Because it's forward, we would like it to be at the maximum negative value. So if direction is forward, this multiplier becomes -1, and -1 the threshold, we pretty much place it at the edge of our threshold in negative side, and it will start moving in forward direction. Same for Z. So let's see how it changed the game. Now, as you can see, the block is spawned not in the middle as before, but it's actually spawned on the edges of our movement threshold, which makes it a bit more visually appealing than before, because it was kind of weird when it was moving, continued to move from the center. Next thing is our speed. Every single spawned movement block has the same speed, and we would like to remedy that. And let's say that we will count the amount of blocks that we have, and based on that count we will increment the speed. So let's say not the count, let's just index something like this. Let's index every single block. So let's say index, by default index is 0, and in our create we can say that something like index is what? +1. Right? So every single spawn block is grabbing the index of the block below it, adds 1, and that is like our counter. And the speed is then increased based on that index. Let's run it again. And after a few blocks, nothing really changed, right? The speed at this point should be like enormous, but it isn't. And this is because we forgot to save our index right here, right? For each spawn block, we need to make sure that the index is updated. If we run it again, and yeah, you can instantly feel that the speed is so much faster. Let's probably reduce it to something like this, so that you can actually place quite a few blocks before the speed is way too fast. Alright, yeah, this increases the speed a bit slower, but yeah, feels much better. And yeah, here is our game over. So when I miss, currently when I do not overlay, I am not able to tell the game that it's game over, and we should probably remedy that. Where's our to do? Right, so if our current block doesn't overlap with underlying block, or the overlap is less than 1%, we need to somehow tell the game that hey, it's game over. So let's do it this way. That PlaceBlock will return true in case the block was placed, and in case there is no overlay, we'll pretty much say false. And then in our GameState update, we can say success is PlaceBlock, and only in case of success we spawn a new one. Otherwise, we're pretty much saying that it's game over. Let's try it out. Let's run a few, and then bam. Current block is no longer visible, it's no longer spawned, our state is game over, and now if I press any button, or not any but space button, we cannot move forward from game over state. So we're currently in this game state, and it doesn't handle any input. Let's fix that. Again, if input is pressed, we need to probably, let's see, init our game, for sure. Before that, we need to free our placed blocks array, and then we probably need to do the same thing as we do for ready state. Let's look at that. Let's place a few blocks here and there. Game over. Let's press the spacebar, and we're once again working. Game over. And new game. Seems to be working fine. Now, one more thing I would like to fix is, of course, the coloring of the blocks. Right now they are all of the same color, and it doesn't look good. It's not visually appealing. So let's try to fix that. In our block, we have this color, and we would like to adjust this color, probably based on the index. And we can make it so that each game has actually different colors, so they are not like the same all the time, by introducing thing like color offset. So let's make a color offset and say get random value. It's not compiled time constant, right? So we are not allowed to invoke this function when we are declaring a const. So let's put a 0 here, and in our init game we can say that hey, current block color offset is get random value from 0 to 100. So this value remains the same throughout the game for all the blocks, and we will use that in some of our color generation. So right now we are simply copying the target color, but we would like to say that, hey, I'm gonna supply some RGB with 255 alpha. And how do we add that? So it will be something like sinus, something like this. So sinus is returning a value from -1 to 1. Then we multiply it by 55. So our interval right here becomes -55 to 55 and plus 200. It's pretty much either its value from 145 up to 255. So well in range of RGB values. Same for G and B. Now in sinus, we will use something like time offset, something like plus 4. You can pretty much supply anything you want as long as like the values differ a bit. And we can say that offset is what? Offset, we can use our color offset, which remains the same throughout the game, plus our index. Right, so offset changes for each new block, and then it is applied to our sinus, and we need to keep track of offset throughout the game. And if we start, yeah, you can see a nice effect where the color changes, but the change is not too significant, right? So you can get a like not a rainbowy, but the color transition is really nice and good looking. The downside of current approach is that our starting block is always of the same color, and I leave it as an exercise to you. If you would like to do that, try to make the first initial place block to use the color given the generated color offset. So right now this is pretty much it for the basic gameplay, right? We still have a lot of things to do, right? So we need to add some sort of transitions, nice animations for our overlays. Right now it's simply is shown, hidden and shown whether the state changes, but we would like to have some fade in, fade out, maybe some movement animation. Our camera right here simply jumps, as you can see, it jumps to the next block, but we would like for the camera to move in a smooth motion so that it's not this jumpy. And when our block isn't like fully overlaying, we cut off the part from the block, and currently there is no animation for this cut off part being like dropped down, which we need to add to the game as well. And there is of course this thing that if we do not draw the wires, right, we don't actually see the shape of this cube, which makes the game a bit weird to play. And for this we will have a separate episode where we're gonna introduce custom shaders, which will add some basic lighting. Should be fun and interesting thing to do. And right now, before we finish off this episode, let's add one more thing right here. No, not right here, but in our place block. So this is where we check whether we have overlapped with an underlying block. And if that overlap is very small, less than 1%, we're pretty much saying, okay, game over. But we can also check for is perfect overlay. So if let's say delta is less than 3, right? So less than 3%, right? We would like to make, or it's actually bool, not if. So we would like to count that situation as a perfect overlay. So when you have pressed your spacebar and our current block is overlapping the underlying block by like 97% or even more, we would like to count it as perfect overlay, and in case it is perfect overlay, then we would like to simply snap it. I think if x and else, right? So size x is target, size x, and current position x is target position x. Same for z. And then, in case it's not perfect overlap, we simply use the logic before when we adjust the position and the size. I don't think it's visible when we play, so I will think whether we can add some sort of effect to the game when that happens. So when the perfect overlay happens, right, we can somehow indicate that hey, it actually did happen. All right, so there is a problem, different problem that I must have. Yeah, the overlay is just too good, so it's not delta. Of course. Yeah, again, the same as here. It has to be an absolute value, right? Otherwise, you saw that I was playing and placing the blocks, and it was like counting it as perfect almost all the time. Yeah, this is a bit better because delta can be either negative or positive, and in case we don't take absolute value, all the negative values of delta always produce perfect overlay. Alright, so this is pretty much it for today. I'm not sure what we're gonna be dealing with in the next episode, and as I said, there are like quite a few things to work with. Probably we will start with animating the overlays, maybe even animating the game over of the tower, so that, although that might need an extra episode in itself. But I hope you liked it. I hope you like this series. I hope you learn a bit from it. And if you like this video, make sure to put that like under the video itself. If you haven't yet, please do subscribe to this channel. It helps me greatly. And I'll see you again. Bye.